The following linear inequality. So we treat inequalities like we treat equations. We're still solving for that variable, we just have an inequality symbol. So I write too big, so I'm going to rewrite this problem here and then I'll move it there so it doesn't bleed, but if you can write small enough to fit on your paper, that's fine. So we want to solve the inequality, express your answer in interval notation, okay? So, have we learned when we're doing inequalities, try to get your variable on the left side. If you get it on the left side, the way your inequality is facing, that's the way you shade. Have we learned that? Okay. So my goal is I'm going to move my p to the left. That becomes a negative 4p. Line it up with my like terms. 2 minus 4 is what? Negative 2p. These 4 p's cancel. 2p minus 4 less than 3. Let's move our 4. Becomes a positive 4. We have negative 2p less than 7. Now we divide by negative 2. And in math, our rule is when you divide by a negative, what happens? We flip the symbol, right? What symbol am I talking about? Yeah. So this less than becomes a greater than because we divided by a negative. So we have p is greater than negative 7/2, yes? So this is called my solution. Everything bigger than negative 7/2. Okay? All right, so we'll go back to our paper. When we solved it, we got p is greater than negative 7/2. And we want a graph. Oh, I'm sorry, hold on. What did the direction say? Use a decimal form, right? As well as write interval notation. So, can I rewrite negative 7/2 as a decimal? Okay, what would that be, please? Negative 3.5. So I have p greater than, p is greater than negative 3.5. Okay, that's a decimal. But we still want the answer in interval notation. But if we can't see that, I encourage my students to graph first, then pull it off of there for your interval notation. So let's go to step 2. How would I graph this that we just solved? We would go to the negative 3.5 on my graph, which is, wait, hold on, 0, 1, 2, this number line's not drawn very well, is it? So we'll make about right here. Okay. Now, this inequality symbol doesn't have an equal bar, so I'm going to have a parenthesis there. Agreed? Which direction? I want the p's greater, yes? So my parenthesis needs to go to the right. And I want everything greater. So once I do my graph, isn't that easier to pull off our interval notation? Okay? So if we pull that off, we should have parenthesis, negative 3.5, and it goes on to where? Infinity. But with these types of questions, we just put infinity. When we were studying in behavior, we would use a plus sign with the infinity symbol, but not with these. So, because we didn't know that yet, did we? Yeah, we just got into that chapter section. So, make sure you don't put a plus sign. We don't do that only with the behavior questions. Okay. All right, so I'll let y'all be able to do 7 hopefully by yourselves. Let's look at 8. Y squared plus 7y plus 10 equals 0. Let's read the directions. What is 8 asking? Solve the following quadratic equation by factoring. If you get a fraction, we have to do what? Okay. So, is this quadratic factorable? Okay. So, what are our possible factors? Let's go left to right. Can I separate the y's first? Y squared, I only got one choice, y and y, yes? No other choices. Then I look at 10, and I heard y'all say, what two numbers can I multiply by to get the middle term? 2 times 5 will give me the middle. 1 times 10 will give me the last. But I need the middle to add up, yes? All right, so plus 2, plus 5. What are these called in parentheses? What are those two sets of parentheses called? Factors, thank you. We take each factor, set them equal to 0, or some of you are doing it in your heads, and we get y equals -5 and y equals -2. So we have how many solutions? Okay, so if we have 2 solutions, that's okay because we have a quadratic. We can have up to 2, can't we? Or we could have 1, or we could have none or imaginary. All right, so we're going to put that on 8. Do we have any fractions to reduce? No. So my answers are, what was the smaller one? -5, comma -2, yes? So it is factorable. All right, let's look at the next page. We have 9, 10, 11, 12. We're recording right here. Please try not to walk right by me. Walk in front. All right, 9, 10, 11, 12. Let's do 2 of those. Let's see. Definitely let's do 11 because I know we're probably not the best with the U substitution, or maybe I'm wrong. And how about 12 because of fractions? Is that okay? All right, so let's look at 11 and 12. I'm going to rewrite because I might be able to fit 11 there. Sometimes I write too big. All right, quadratic like comes from section 2.4. So do we recall the U substitution? Y'all were absent that day? Hopefully not. All right, so what I try to share with my students is the best way to do quadratic like is you focus on the B term. What is the B term in my problem? If we write a quadratic, AX plus BX plus C, where's the B located? In the middle, right? So right here. So if we focus in on the B, which is 6, Z minus 2, that's the one that always works. So I would set my B value equal to U equals Z minus 2. It works every time. I promise you that. So what we're trying to do is we're trying to put this in a form that we can solve much more quickly and a little bit easier. So every Z minus 2 I see, I'm going to replace it with a U. So I have a Z minus 2 right here. I'm going to replace that with a U, and then I'm going to square it. Minus 6, I'm going to replace the Z minus 2 with a U. Plus 8 equals 0. Now, doesn't that quadratic look a lot nicer to try to solve? Okay? Is it factorable? Okay? So, my possible factors, U times U. And then for 8, what do I need so I get a -6 in the middle? Minus 2, minus 4. Because I need a -6. Set these equal to 0. U minus 2 equals 0. I get U equals 2. U minus 4 equals 0. I get U equals, they're both positives, right? We should have done that in our head. But we're trying to write it down so it's on the video. You can look at it later. All right, so we got u equals 2 and u equals 4. But our problem had the letter z, so we have to substitute back in what we just pulled out. We pulled out z minus 2, yes? So this u now becomes z minus 2 equals 2, and this u becomes z minus 2 equals 4, and we have to solve for z. So we get z equals 4 and z equals 6. Okay. So so our solutions here are 4 and 6. Oh, sorry. Oh, thank you. Sorry if my z's look like 2's, but that's a z, okay. So we got 4 and 6, yes? This is me, that's my anal from my class. I like braces, okay? So when you're doing quadratic like, you substitute for u, and then you have to substitute back in based on the letter they're giving you in the problem. Is that clear? Yes, no? I want to make sure y'all get this, because we just wrote the final exam. I'm telling you, you're going to have a quadratic like equation. Can we do this? Okay. Question? Okay. 12. Solve. Y'all love fractions, don't you? So we made sure every other question on the final had fractions. Is that okay? No, I'm just teasing. Okay. But I know y'all like fractions. Y'all go to the store and you know when something's on sale, and all of a sudden, miraculously, y'all can do fractions. But in class, y'all act like y'all don't want to do fractions. All right, so we want to solve this. The directions say solve the rational equation. Why is this a rational equation? What makes it a rational? Yes. Because it has a, well, that would mean we have a quadratic in there. But for the word rational, if we remember our guide pictures, all the graphs you learned for the transformations, when you have fractions, you have rationals, yes? Yeah, that's why they put that word in there. Math, they like to throw these words in there just to throw you off. You can't let them do that, okay?
Do you mind clarifying what you said again? You said if there's fractions, it's rational?
The directions say solve the following rational equation. But some of y'all might read this and, well, I don't know what that is. I'm just going to solve. Rational means we have fractions in our problem. So, yeah. All right. So in order to solve anything with fractions and subtraction, we have to have our LCD be the same, yes? Or we can get rid of it. But we don't know. We know this is z minus 5. We know this is z plus 7. But we don't know this denominator unless we factor it. Is z squared plus 2z minus 35 factorable? Okay, what are my factors? If you remember when we covered this, chances are one of your denominators over here turns out to be one of these possible denominators as well. So let's see, z times z, I need negative 35 with those two factors to equal 2 in the middle. What are my factors of negative 35? Negative 5 and 7. Or I could flip the sign, but I need to make sure I get a positive 2, yes? All right, so signs are important. Okay? So I'm going to cross this out because I'm going to use those as my denominator, not the quadratic, okay? Now, we can visually see we have these two are right here inside of this quadratic, yes? Okay. So now here's my question. What does LCD mean? Okay. So the least common denominator. What denominator do all of these denominators divide into evenly? Okay, let me say it this way. If I have 1/2 minus 1/4 equals 1/8. Let's use numbers, no letters. Can 2 divide into 4? Okay. Can 4 divide into 2? No. So that means 2 can't be my LCD. Okay, now I go to 8. Can 8 divide into 4? Where are your calculators at? Type in 8, division 4.
Yeah.
Okay. Can 2 divide into 8? Hold up. Am I in the twilight zone? Hold on. 2 divided into 8? Wait a minute. Where's my calculator? Okay. So 2 can divide into 8, 4 can divide into 8, but when you say it the other way, you can't put what? 8 divided into 4, 8 divided into 2. So even though we're saying least common denominator, sometimes it turns out to be the larger denominator. Is that clear? We want the least number that everything divides into evenly. So for this problem, 8 would be my LCD. But in our problem, can z minus 5 divide into z plus 7? No. Can z plus 7 divide into z minus 5? No. But can they divide individually into these two? Yes. So my LCD is the larger one, just like the 8 here. You can justify anything in math, replace letters with numbers, and that's how you can prove if you get lost or turned around. Okay, never mind. Y'all look at me like, whatever. Okay, here we go. My LCD is both of them together. So what we're trying to do is get rid of the fractions because y'all don't like fractions. So that means we're going to multiply. Let me take a step back. How many terms in my original problem? 1, 2, 3. We have 3 terms. That means I have to multiply my LCD 3 times to get rid of the fractions. I'm trying to write back. This is hard sideways. Okay. So z minus 5 times z plus 7, that's my LCD, times the first term, z over z minus 5, minus the LCD again, z minus 5 times z plus 7 times the second term, 8 over z plus 7 equals my LCD again, z minus 5 times z plus 7 times the last term, which is the long one we have there, z squared over z minus 5 times z plus 7. Now, some of us are doing this in our heads. Great. But what we're doing is we're trying to get rid of, this doesn't let me get small. Go back. We're getting rid of the fractions. Z minus 5's cancel. Bam, gone. Z plus 7's cancel. Gone. Z minus 5 gone. Z plus 7 gone. I can crisscross. Now I'm left with z plus 7 times z, fraction is gone, minus z minus 5 times 8, fraction gone, equals z squared on the end. By multiplying by the LCD, we're able to get rid of all the fractions. That's what we're doing. But you don't have to write all these steps. Mathematically, that's what's happening, okay? But we still got to solve. Z times z, z squared. Z times 7, 7z. Over here, I'm going to put my minus. I'm going to distribute my 8 first. 8 times z, 8z. 8 minus 5, negative 40. Or if you were really good, you multiplied the negative at the same time. I just don't want to lose anyone. minus 8z, distribute your negative, pop plus 40. Am I still on the screen? Okay. Combine our like terms. Z squared equals, plus 7z minus 8z, negative z, or negative 1z. Do y'all like writing the ones in front? Okay, good. Plus 40 equals z squared. We're a little closer, right? So, do you see we have two z squares? Those are like terms. So let's move the z squareds together, and what happens? Okay, so now we have an even shorter equation. Negative z plus 40. This is 0, not 1. And now we're just solving for z, which is what? 40. Well, hold up. We're not done. Because we had fractions, yes? And when you have fractions, what do you always avoid in the denominator? What do you never want in the denominator with a fraction? A 0. Why? Undefined. So we got 40, which means we have to go back and double check. If I put 40 here for z, do I get a 0 in this denominator? No. If I put 40 here, do I get a 0 in this denominator? If I put them together, I still don't get it. My point is, if I had a 5 and I put it here, that would be undefined, which makes this no solution. Anytime you have fractions, you have got to check in your head, does it work, before you say I'm done. But I'm done because 40 doesn't give me a 0. So my solution for number, 12, is 40.